This is Team EDS. I'm going to do a walkthrough for Lab 9, the chatbot's command line interface. So the chatbot uses information from a single PDF to answer questions. This is done locally using open source model, the Llama 2 as the main language model, and a sentence transfer model for understanding text meaning. The specific PDF we are using is the ADS Circuit Design Cookbook. As the code is executing, I'll break down what I've done. It all starts with a Docker container. To make sure everything runs smoothly with all the complex libraries, the setup is done inside a Docker container. Now, the first part, indexing. This is when the script starts. It first reads the PDF document, which is the ADS cookbook. It breaks it text into smaller chunks. Then it uses embedding model, which is the sentence transformer, to convert each chunk into a numerical representation, basically turning its meaning into numbers. These numbers are then stored into a special database called a vector store. It's like creating an index for the PDF. The script then uses embedding model to understand the question and searches the vector store for the text chunks from the PDF that are most similar in meaning. After that, it takes the original question by the user plus those relevant PDF chunks and feeds them together to the main language model, which is Llama 2. The model then reads the question and the provided text snippets and then generates a natural language answer based on that information and only that. So as you can see, the script will confirm once the conversation chain has been created. Then we can ask the script certain questions through CLI. For example, if you ask it, how do I install the circuit design tool? It will print thinking. This essentially is the slow part where the model is processing the input and generating a response. If we look at the answer, we can see the only document the chatbot knows is the cookbook PDF itself. It searched the PDF, found relevant text to circuit design tool, and install, download, which likely pointed to instructions. And it generated answer based on only that. This is a main code for the command line interface. There are different helper functions and a main driver functions, which the driver function plays a role in executing the question and answer loop with the help of different helper functions. This is the Llama 2 model that I've used, specifically the 4M version. That's it for the command line interface. Now my teammates will explain the further implementation that we've done.
Hello, Shivani from Team ADS. Here to, so I have worked on the part where I have tried the data OpenAI embeddings. OpenAI embeddings. So it's the PDF and breaks the text into bite-sized chunks, converts it into chunks, those chunks into numerical vectors, stores them, and uses the chat model to answer questions used to store the text. Uh, for the first step, we have so the code opens every PDF in the folder and extracts the text from each page. It gives us one big block of text basically per PDF. And then the second step is chunking it. Okay. Yeah, so right here. Uh, so the text is split into smaller pieces called as chunks. So the chatbot can find relevant passages more quickly. The script prints how many chunks are created. Then the third is embedding and vector storing. Each chunk is now converted into numerical embeddings using the embedded model. These vectors are saved in the vector store so that we can quickly find similar chunks. And the script is basically built in a way that we can retrieve this chat pipeline. So when you ask a question, it finds the top matching chunks and passes them into the chat model and returns the answer. You must also set your API key in the environment file and or environment variable. Basically, there are options. So we have tried using OpenAI, Hugging Face, and Azure OpenAI. Also, or any like also we have implemented the local fallbacks, but those are in like part 3. So yeah, this is all from my side. My other team members will explain the rest of the part as the API requests are limited. We have tried implementing using different open source models. Thank you.
Hi, my name is Day, and I am part of the ADS team. We have built a PDF Q&A introduction and chatbot using Streamlit, LangChain, and Llama 2. It basically lets users upload PDFs and let them ask questions, and it runs entirely on your device where no cloud APIs are used. Front end for this includes Streamlit, back end includes LangChain. LLM we have used is Llama 2, 7 billion with 7 billion parameters. The vector database that we have used is FAISS. Embeddings are sentence transformers, all mini LM. The hardware used is the M1 Pro with Metal GPU and the GPU. There are 32 GPU layers. So basically, let me show you the demo for this. So here, as you can see, I've already selected a file. I will then click on Process PDFs. It will start processing the PDFs. Uh, the text is split into 27 chunks, and the PDF is processed successfully. And we can see the process files here in the Lab 7, and the process file here is Lab 7. Now, let's ask a question. What is the document about? We are just asking random questions to see how it is performing. Yeah, so it basically give a short explanation. The document is about setting up mobile phone-based IoT network using the OwnTracks app, which is basically our Lab 7 task. And let's ask what are the requirements of the lab. So it might take some time to answer. As you can see, this will give the basic requirements of the assignment based on the contents of the PDF. It includes a mobile phone with Overtrax app installed and account profile page. So these were the basic requirements that were listed for Lab 7, uh, which we needed to have in order to complete the assignment. So basically, the technical architecture of this system is divided into several parts, which includes like extracting text from the PDF, then chunk via character text splitter, 500 characters with 100 overlaps, embedded with sentence transformers. This is stored in FAISS. So on query retrieval, top two chunks, built prompt with context and question, and it will generate answers with Llama 2. So uh, Basically, the performance optimizations include GPU offloading with 32 layers on Metal using NGPU layers as 32, precision of 16-bit KV cache, and retrieval of top key reduced to K in order to make the retrieval faster. As a result, we are getting the responses in about 5 to 10 seconds. The key features includes full local processing, no internet required, convolutional memory with LangChain, upload multiple PDFs in one session, Streamlit session management, and privacy preserving. So the code structure is basically divided into two different files, which includes the Streamlit app file, which is the main file for the app, and the execution model CLI. Uh, doc.py file, which includes processing functions such as PDF extraction, chunking, embedding, chain reaction, etc. And a single file. This is a single file architecture in order to make it simple. And this basically can process uh, PDFs right now. We can also extend it to process docs text as well.